Looking at this fraction is a little bit different than the other complex fractions that we've dealt with. However, we can make it look like the other complex fractions. But first of all, we have to know what these negatives actually do to this. Okay, so before we move on, let's think about that and go through an explanation. So let's go over here to a nice clean sheet. So we have x to the negative 1 equals 1 over x. Basically, this means that any time that you have a negative exponent in the numerator, you can easily bring that down to the denominator to make it to have a positive exponent. Okay, so that's what happens with all of these, that if you have a negative exponent in the numerator and you bring it down to the denominator, you have a positive exponent. If you were to have a negative exponent in the denominator and move it to the numerator, then that would become positive. So basically what happens if you switch them from numerator to denominator or from denominator to numerator, then it changes the sign of only the exponent and nothing else. So even if you had something like 2 to the negative 1, we know that there's a 1 underneath this 2 that's implied. And so if we were to move this down to the denominator, then we'd have 1 divided by 2 to the first, which is really, of course, just 1/2. Likewise, if you had something like 1 over 3 to the x, and let's say that that's actually in negative 3. That's actually raised to the power of negative 3, so that when you move it up, remember it's the whole entire quantity, so that when you move it up, you actually have 3x and that quantity raised to the third. And of course it's over 1. But remember, it just can be simply written as 3x to the third. Or if you want to go even further with it, you could go ahead and distribute this 3 through. So you could say that that's going to be 27x cubed, if you'd like. That's going to be another video, so if you want to, please scroll videos and search for the ones that you need to know, especially about this idea here. So, with that, let's go ahead and, again, look at this problem. So, now that we have these negative exponents, we know exactly what they mean and we can change them into that. So let's do that. So we have 1 over x divided by 1 over x squared plus 1 over y squared. So see how I just moved everything from the numerator to the denominator, thus changing the signs of only the powers. Okay, so now this is much like the previous video to where we had one fraction up here in the numerator, and notice now we have 2 fractions down here. So we need to make this into 1 fraction, and we simply do that by finding the least common denominator, which I'm pretty sure you're familiar with by now. So we're going to have that LCD of x squared times y squared. And so we need to multiply this guy by y squared divided by y squared, so we can get a y squared here. And we need to multiply this guy by x squared over x squared, so we have plus x squared. So now notice we have a fraction here at the top and a whole fraction here in the denominator. So now all we have to do is use the idea of keep, change, flip. So we're going to keep the first fraction, which is 1 over x. We're going to change the sign from division to multiplication, and then we're going to flip the last fraction, which would be x squared times y squared divided by y squared plus x squared. So now notice there are 2 x's in the top and 1x in the denominator. So what we're going to do is we're going to cancel that out, and that's actually just going to be x to the first. So we now have, just multiplying straight across the top, we've got x, y squared, all divided by y squared plus x squared. And if you'd like, you can make this bottom part have the x squared comes first. It doesn't matter, because you have to remember that a plus b equals b plus a.